So where did we stop in the last class? We were talking about the memory management, the garbage collector, how to call the garbage collector, and all such things, right? Yeah. There is one last thing which I need to tell you people regarding the garbage collector. Okay. Yes. What is it? Let's see. Garbage collector, as I told you people, it is responsible for uh, cleaning up the heap memory. I can say it is responsible for cleaning up the heap memory. So what it does basically, it will identify the unreachable objects. Okay, it will identify the unreachable objects, the objects which are unreachable, which are not reachable, and it will reclaim the memory of that unreachable objects. Yes. So you know there is an important point which you need to know here. The garbage collector, after identifying the unreachable objects and before it reclaims the memory of that unreachable objects, before it reclaims the memory of the unreachable object, it will call finalize method on that object. It will call finalize method on that object. Finalize method. So what is finalize method? So is anyone familiar with this finalize method? Yes. What is finalize method? Where did we saw this finalize method? We came across this method definitely, but I didn't talk about it though. Where is this finalize method? No, no. Finalize method. It's method. No, I'm not talking about keyword. Yes, finalize method is actually defined in the object class. Okay, yes. It is used to close all the unused references. Okay. Uh-huh. Just a second, please. Just a second. Yeah. Okay. So finalize method, you'll find that finalize method is used to, you know, it is used to write the cleanup code, I can say. Finalize method is used to write the cleanup code. Yes. I can say that it is actually cleanup code. Yes. So finalize method is actually defined in the object class. Yes, that's right. Finalize method is defined in the object class. Finalize method is invoked by the garbage collector when it decides to reclaim the memory when it decides to reclaim the memory of an object. When it decides to reclaim the memory of an object, it will call the finalize method on that object. So when it decides to reclaim the memory of an object. So, you know, by default, the finalize method of the object class in the finalize method of the object class, you won't find any functionality. I can say that it's a blank method. Okay. The finalize method of the object class, you see, it's an object class method. Okay. Yes, you'll find that this is one of the object class methods. Again, we are talking about object class method in the memory management. Yes. So it is related to memory management. So I'll show you people. So so the finalize method of the object class, you see, we have it, the last method. It's a blank method, I can say. Basically, it's a blank method. And in this finalize method, you'll write the cleanup code. Finalize method is used, I can say that. Finalize method is used to write the cleanup code. Finalize method is used to write the cleanup code. So what is cleanup code? What is cleanup code? What is cleanup code? So cleanup code means, I can say that it is actually nothing but the code which we write to release the resources which are required. Okay, cleanup code is nothing but writing the code to release the resources which have been acquired. Releasing the resources which have been acquired by the object earlier, or by this object earlier, I can say. Releasing the resources which have been acquired by this object earlier. So what do we mean by resources here? Just a minute. Just a minute. Sorry. So sorry. What are resources? What do we mean by resource? Is it memory? That's it. What are resources? What are resources? Resources means they're saying releasing the resources. So what does that means? You know, maybe it is too early for us to talk about any resource, but I can say that as of now, you can think of a resource as any object which is needed, which is needed for this object to accomplish a task or a goal. Resource, I can say that basically it is any object which is needed for this object to accomplish a task or a goal. You know what? In Java, you'll find that it is object oriented. So each and everything in Java, it is actually represented as an object. It is represented as an object. Yes. Okay. So for example, I'll give you an example for a resource. A resource can be, example of a resource can be connection object. So what is this connection object? So basically, if you want to interact with the database server, if you want to interact with database server, so you need a connection object, I can say. You need a connection object. That means you, in the sense, the application needs a connection object. It has to acquire the connection object. Then only it can interact with the database server. So once that application is done using it, or once that you see, basically, when I say application, you may have several objects in the application. So one of the objects in the application, it might be, or it may need this connection object. It may need this connection object. So to interact with the database server. So once it is done using it, you see, it has to close it. Or even when that object becomes unreachable, it is better to close that connection object. So you see, closing that connection object, it is called as cleanup code. Closing the connection object. Once you're done, once you're done, yes, once you're done using that connection, you have to close the connection. You see the way. Once you're done, okay, let's say you'll dial your you'll call your friend or anyone from your mobile. So a connection is established between your mobile and your friend's mobile. Once you're done talking to your friend, you'll close the you'll cut the call, right? Similarly, Java applications objects, they may need to interact with the database server, so they use this connection object, which represents a connection between the Java application and the database server. Once we're done using that connection, it has to be closed. It has to be closed. So, you know, that code which we write to close the connection, the code which we write to close the connection, so that code is actually called as cleanup code. I can say that code is actually called as cleanup code. Okay, so releasing any resources, such code is called as cleanup code. Yeah, this is an example. A connection object is an example. So once you're done using it, you have to close it. So any object which has acquired this connection object, now it has to close it. Okay, and you see, even when that object becomes eligible for garbage collection, you see, if the object becomes eligible for garbage collection, what does that mean? That means that object is not accessible or it is not reachable. That object is not accessible or it is not reachable. So if that object is not reachable or if it is not accessible, then you'll find that whatever the resources which are required by that object, they are of no use, right? Even this connection object, if it is acquired by that object, now it is of no use. So it is better to close it. Okay, yes, that's it. So hope you people got it. As of now, we can't see that code. Okay, don't worry, but soon I'm going to show you people. At this point of time, just make a note of this point. Just make a note of this point. Definitely, you'll come across this cleanup code and all. You will know. You'll definitely know. You'll learn. Soon see that you're going to see this a kind of code where we close the connections and all. That means resource cleanup code. You can see. We'll be writing such cleanup code. Okay. Soon you're going to do that. Fine. So we use finalize method to write the cleanup code. You can see. We use finalize method to write the cleanup code. You can see. Okay. Fine. So when this finalize method is invoked, when this finalize method is invoked, yeah. So the garbage collector, when it decides to reclaim the memory of an object, the garbage collector, when it decides to reclaim the memory of an object, the garbage collector, first of all, it will call the finalize method on that object. Once that finalize method finishes execution, it will reclaim the memory of that object. So why it calls a finalize method? Because in the finalize method, you got the code, the cleanup code, which is used to release that resources. So if this object, if it holds any resources, if it has acquired any resources, so that resources will be closed. Okay, yes, fine. So this is the last thing which I would like to tell you people about finalize method and the garbage collection. So let's move on. Now, I've got few tasks for you people which I'll give you later on, which are related to the memory management. But I'll give you people at appropriate time. Don't worry. Okay. Yes. Now, what we're going to do is here, we'll talk about the next topic, that is exception handling. So, I'll make you people understand memory leaks. Okay. We got something called as memory leaks, but I'll do it later on. So at appropriate time, we'll talk about it. Yeah. Okay. So let's see this exception handling. So before we talk about exception handling, so first of all, you need to understand what is an exception. So what do you people think? What is an exception? Okay, so exception is a runtime error. Okay, fine. Yeah. So first of all, before we start, I got something to tell you people. So what is it? You know, uh, you need to clearly understand the difference between, you need to clearly, you should be able to understand the difference between runtime and compile time. It is not public because uh, we want to make sure that it is inherited only in that particular subclass. It is inherited only in the subclass. Just a minute, please. Yeah, I'm sorry. Yeah, so hope you got it. So it is protected so that it is inherited only by the subclasses and it is overridden. You can override it or you can access it. At any cost, the protected method should be visible to subclass. Okay, so exception. So you need to understand the difference between the runtime and compile time. So what is the difference between the runtime and compile time? Is, you know, during the compile time, the compiler will check for the syntax errors during the compile time. The compiler will check for the syntax errors. You know, if there are any syntax errors during the compile time, if there are any syntax errors during the compile time, then the compiler will throw that errors. They're compile time errors. They're actually called as compile time errors. Okay, they're called as compile time errors. You know, but you'll find that the errors, they may occur during the runtime also. You know, the errors which occur during the compile time, the errors which occur during the compile time, you'll find that those errors most of the times they are syntax errors. Those errors are actually syntax errors. So syntax errors means, you know, if you don't follow Java syntax properly, you're going to get that error. If you don't follow the Java syntax properly, you're going to get that error. Yes. If you don't follow the Java syntax properly, you'll get that error. But you know, the errors may occur during the runtime also. So when I say runtime, during the runtime, whatever the instructions which I have written, they will execute. Okay, during the runtime, whatever the instructions we have written, they will execute. And you know, during the runtime, if there is any error, we call it as an exception. During the runtime, there can be an exception. During the runtime, there can be an exception. Okay, so that means when the program is executing the instructions, when the program is executing the instructions, you may get an error. So such errors are actually called as exceptions. Such errors are actually called as exceptions. Such errors are actually called as exceptions. So error, I can say that exception is an error. Exception is an error which occurs during the runtime. So an error or an exception, sorry. So when an exception occurs, it may disturb the normal execution flow of the application, or it may cause the program to or it may cause the application to terminate abruptly in the middle of the execution. So exception is an error which occurs during the runtime. When an exception occurs, it may disturb the normal execution flow of the application, or it may cause the application to terminate abruptly in the middle of the execution itself. Yes. So there are two possibilities. When an exception occurs, it may disturb the execution flow of the application, or it may cause the application to terminate abruptly in the middle of the execution itself. Yes. So there are two possibilities. Okay. So please make a note of this first of all. Okay, so before we move any further, first of all, we'll try to we'll try to produce an exception. We'll see how this exception looks like and we'll discuss more about it. Yes. Okay, so for suppose let's take this example. So for suppose I'll make this reference null, and then we'll call this withdraw method. We'll call this withdraw method. So after making that reference null, using that null reference, I'll call that withdraw method, and then we'll add a statement end of main method. Okay. End of main method. So if we call a method, using the null reference, then what happens? If you call a method using the null reference, then what happens? Yes. You'll get null pointer exception. Yeah. In line number 14, you'll have null pointer exception. In line number 14, you'll have null pointer exception. So when an exception occurs now, what exactly happens? What exactly happens? Yeah, in this case, I can say that we are not handling the exception. So in this case, we are not handling the exception because we are not handling the exception here explicitly. You'll find that the program terminates abruptly in the middle of the execution itself. That means, so the application will stop in execution here in line number 14 itself. So that means line number 16 will not execute. There is no scope for the line number 16 to execute. Okay. So you'll find that this program terminates abruptly and that line number 16 will not execute and it will not print any message here. You see, there is a null pointer exception. It says there is a null pointer exception. Yes. So that line 16 did not execute. Line 16 did not execute. I can say. Okay, so in this case, the program terminated abruptly in the middle of the execution itself. So if you want, we can handle this exception. So how can we handle the exception? So for that, we have to use try catch block. Use try catch. Use try catch. I'll add the statement after the catch block. We'll do this. Let's say line number 16. Let's do this. So just a minute. You know, Java, it provides as an option to handle that exception. It provides as an option to handle the exception. So we can use this try catch block for that purpose. We can use try catch block for that purpose. Okay. So now this time there will be an exception in line 14. So you know what happens here? So when there is an exception in line 14, so after that what happens? So straight away, because you see we got an exception in line 14, you will find that straight away the catch block will be called. So when the catch block is invoked, you see, you will find that it prints that catch block. After this statement executes, after the catch block executes, you see, what's next? What happens next? Can you people tell me? What happens next? So the statement will it execute? But previously it didn't execute, right? Previously it did not execute. So hope you got the point. Yes, this time it will execute because we are handling the exception, I can say. This time it will execute because we are handling the exception. So this time, can I say that the program has executed abruptly in the middle of the execution? Can I say that the program has terminated abruptly in the middle of the execution? No. Program, this time, it did not abruptly terminate in the middle of the execution, you can say. But what happened here? You will find that the normal execution flow of the program is disturbed. How? You see, when there is an exception in line 14, straight away the catch block executes. And after the catch block executes, you see, if there are any statements after the catch block, they will execute. So the statements between line number 14 and catch block, they will not execute. Okay? They will not execute. So hope you got it. So let me run this code. This time, what happened? The normal execution flow of the program is disturbed. See, it executes catch block, end of main method, but that line number 16 it is not printed. Yes. So now let's move on. Here, you need to understand what exactly happens. So when an exception occurs, what exactly happens when an exception occurs? Okay. So basically, Java is object-oriented programming language, right? In Java, everything is represented as an object. Even exception is also represented as an object. In Java, even exception is also an object, I can say. So hope you got the point. Even an exception is an object. You'll find that this exception object is basically used to store exception details, or I can say error details. That exception object is basically used to store exception details or error details, I can say. When I say an exception object, that means for this exception object, you will have an appropriate class, right? So you see, this is just like this exception object is just like any other Java object. This exception object is basically just like any other Java object, I can say. So far, we have created Java objects. So what is the purpose of the Java objects which we have created so far? Yes. What is the purpose of the Java object? Java objects. We have created a lot of Java objects so far, right? So what is the purpose of creating those Java objects? What did we do with those Java objects? Is you see, basically in the Java objects, you'll store some data, right? In Java objects, you'll store some data. For example, we have created savings account objects. So in the savings account object, we got savings account details. In the savings account object, we got the savings account details, right? So similarly, we have created employee objects to store employee details. We have created item objects to store item details. So similarly, we got an exception object which represents errors. In that exception object, you'll store the error details, I can say. So exception classes are special type of Java classes, I can say, in which you have the error details. Exception objects are special type of Java objects in which you have the error details, I can say. Yes. So that is the specialty about the exception classes. Basically, they represent the errors, exception classes. You will find that for each type of error, for each type of error, there is an appropriate exception class. For each type of error, there is an appropriate exception class, I can say. For each type of errors, there is an appropriate exception class. So now, even in our case, an exception class object is created. So which exception class object is created here? Let's see. So if you want those details, you can just call this print stack trace method. In the exception class, we have a method called as print stack trace. Call that method, you'll get more details. Okay. Now, can you, by looking at this error, can you people tell me which exception class object is created? It creates null pointer exception class object. It creates null pointer exception class object. You see, this details, you got the package details. Java dot lang dot null pointer exception. That means the null pointer exception class is in Java dot lang package. The null pointer exception class is in Java dot lang package, you can say. Okay, yes. So now I'll make you people understand how this mechanism it works exactly. Let's see when an error occurs. So what exactly happens when an error occurs? What exactly happens? Let's see. You see, in our example, when this line executes, when that line number 14, when it executes, what happens? It will an error will occur. I mean, an exception will occur, right? So because there is an error in that line, internally an appropriate exception class object is created. In this case, okay, we got a null pointer exception. In this case, we got a null pointer exception. So framework is going to create null pointer exception class object. Because there is a null pointer error, framework will create a null pointer exception class object. So we have a class called as null pointer exception. So that null pointer exception class object is created. So after internally it is created, okay, we don't have to write any code for that. After creating that null pointer exception class object, you see, into that object the error details are stored. Into that object you will find that the error details are stored. So after that exception object is created and the error details are stored in that exception object, so that exception object is handed over to the runtime system. After that exception object is created, it is handed over to the runtime system. So what is runtime system? Yes. So null pointer exception means it is basically, sorry, runtime runtime system. I'm sorry. Runtime system means it is nothing but the JVM in execution. Runtime system means the JVM in execution. That is runtime system. Sorry, yeah, that is runtime system. So when an error occurs, you see that exception object is created and it is handed over to the runtime system. So what exactly the runtime system will do with this exception object? So you need to understand that. That's very clear, very important. What exactly the runtime system will do with that exception object? What exactly the runtime system is going to do with that exception object? You know, the runtime system, it will take that exception object and it will check whether there is any exception handler, if there is any exception handler. What is an exception handler? What does it mean? Exception handler. Yes. Yes. What is exception handler? Exception handler means your try catch block. Yes. Your try catch block. See, we write try catch block, right? It is exception handler. So, JVM will check whether there is any exception handler in the program. So, you see, in this case, we got an exception handler, got a try catch block, right? And you know that in the try block, we got an exception. In the try block, we got an exception. So, you see, Because the runtime system finds a exception handler, it will check whether there is any appropriate catch block to handle that exception. I can say that as of now this catch block is appropriate for handling that exception. Which exception? Null pointer exception. So the runtime system will call this catch block and it will pass that exception object reference. You see here we have E. E is basically a reference variable of type exception class. Okay, so that is a reference variable basically. E is a reference variable which can take exception object reference. So now the runtime system will call this catch block, right? So it will pass that exception object reference. Now in the catch block, you can write that exception handling code, whatever it is, displaying that error details. Or if you got anything else to do, we can write that code. That's it. So after the catch block finishes execution, you'll find that if there are any statements after the catch block, they will execute. If there are any statements after the catch block, they will execute. For suppose, let's say, what if there is no catch block? In this case, what happens? The runtime system, what it does? Okay, you see, when an exception occurs, the runtime system will create an exception object, will store the exception details in it. Not runtime system, that means internally. Internally, when an exception occurs, an exception object is created and it is passed on to the runtime system. Now the runtime system, it will search for the exception handler. You see, in this method actually we got the exception. So the runtime system will check whether there is any exception handler. So there is no exception handling code. There is no try catch block, right? This time what happens? What do you people think? Object, okay. You know what? In this case, if the runtime system fails to find an appropriate exception handler, if the runtime system fails to find an appropriate exception handler, there is no exception handler here in fact. So what it does is it will call default exception handler. It will call default exception handler. Yes. Okay. You know, The default exception handler, it is actually associated to the main method, I can say. Default exception handler is associated to the main method. Only for the main method you'll find default exception handler. Okay. Default exception handler, it will print the error details and simply terminates the program. It terminates the program. That's it. So for every main method, you'll have a default exception handler which is associated. Okay. So here, so because we didn't handle the exception, the runtime system, it fails to find the exception handler. Okay. So it will print. So it will the runtime system will be invoked. So which will print that exception details. So to that runtime system, that exception object is passed on. So runtime system will read that exception details and simply it will terminate the program. That's it. So this is what the default handler does. So it is only responsible for taking that error details or exception details. It will print the error details and it terminates the program. That's it. That is what the default handler does. It is by default applied to all the main methods. Okay, so hope you people got it. So if you handle the exception, then what happens? You see, whatever the statements which you got after the catch block will execute. So the program or the application will not terminate in the middle of the execution. Okay, now let's do one thing. Let me add this try catch. We'll go through exception class hierarchy once. We'll go through exception class hierarchy. You know, in your Java API, we got this exception class hierarchy also. In the exception class hierarchy, we got various exception classes and the root of the exception classes and the root of the exception classes, exception class hierarchy is exception itself. We will see that. There is no, we can't define the flow that way. It is not possible to define the flow that way. Okay. So exception class is considered as a root of the exception class in the hierarchy. It's a superclass of all the exceptions in Java. Exception class is superclass of all the exceptions in Java. Yes. So I'll show you people the exception class hierarchy ones. You know, in the java.lang package itself, you'll find exception class summary or exception summary. You should see exception summary here, you see. And one of the classes is exception class. This is just like any other Java class. Exception class is also just like any other Java class. So what is the difference between exception class and a normal Java class? You see, these are all the subclasses of exception class. The very big subclasses. There is a very big list of subclasses here, you see. So many subclasses for the exception class. So what is the difference between exception class? You see, it's just like any other Java class, as I told you people, right? It has also got subclasses. It's just like any other Java class. So what is the difference between exception class and a normal Java class? I can say that exception class, it represents errors. Exception class basically, it represents errors. Right? So that exception class is also just like any other Java class, but it represents an error, I can say. Basically, it represents an error. Okay. So we got exception class. Now there is a subclass for exception class. What is the subclass of exception class? Runtime exception class, you see. Now we have null pointer exception, right? We have null pointer exception. So null pointer exception is also a subclass of the exception class, but it is not a direct subclass. So null pointer exception also is a subclass of exception class, I can say, but it's not a direct inheritance. So this type of inheritance, what it is called as actually, yes, multi-level inheritance. So what you're looking at is, and again, it's an example for multi-level inheritance. So null pointer exception class is one type of exception class. It represents one type of error, I can say. Yes. Now let's go back. You see, there are a lot of subclasses for the runtime exception. Even arithmetic exception is one of the subclasses. So this is a subclass of runtime exception. Fine. Now, you see this reference in the catch block, we are declaring that reference variable, right? So what is exception? It's a class. What is E? The reference variable. E is a reference variable, I can say. So what is the purpose of this reference variable here? Why we are declaring that reference variable? Yes. Just a minute. Let me connect to the adapter. Just give me a couple of minutes. Just a couple of minutes. Sorry, sorry. So can you people hear me? Okay, good, thank you. So, you know, this this part of the statement in the catch block, you see, what exactly it is? It is declaration of reference variable. So that reference variable is what type? Exception type. That reference variable is what type? Exception type. So, as I told you people, the runtime system, it will it will call this catch block when there is an exception. Okay. First of all, internally an exception object is created, it is handed over to the runtime system. So runtime system in turn, it will call this catch block, and it will pass that exception object reference. As of now, you see we have this catch block, so which takes at exception class reference. But in our example, actually which class exception object is created? In our example, in our case, which class exception object is created? Null pointer exception class object is created. So that null pointer exception class object reference, runtime system will try to pass it to this catch block. But now here I have a question. So this catch block, will it be able to take null pointer exception class object reference? So into this reference variable E, can we store null pointer exception class object reference? Into this reference variable E, which is of type exception, can we store null pointer exception class object reference? Is it possible? It is possible. Yes. Why it is possible? How so? Exactly. That's right. Very good. So exception class is actually super class of null pointer exception. So we can store null pointer exception class object reference in exception class reference variable. Yes, it is possible. Okay, it is possible. Okay. Now, can I change this reference variable type from exception class to null pointer exception? Can we do this? Yes, it is possible. It is very much possible. You know, we can do this. But now, into this exception class, into this catch block, or this catch block you see here, this time it can only take null pointer exception plus object reference. So this catch block here which you got, it is appropriate to handle only null pointer exceptions, I can say. This catch block can only handle null pointer exceptions. Okay, so this works fine, absolutely, without any issues. Okay, let me run this code. See, it works fine. For suppose, what if I change this reference variable type to runtime exception? What if I change this reference variable type to runtime exception? So can we store that null pointer exception class object reference in this into this runtime? Yes, it is possible. But for suppose, what if it is arithmetic exception type? What if I change this reference variable type to arithmetic exception? So is there any relationship between arithmetic exception and null pointer exception? Is there any relationship between null pointer exception and arithmetic exception? No, they're not related actually. Okay, null pointer exception class is different and arithmetic exception class is different. So they both are different. They both are different. So that means, can we store null pointer exception class object reference into this arithmetic exception class reference variable? We cannot, right? It is not possible. It is not possible. That means this time, if I run this code, what happens? So when there is an exception, this catch block, will it be node? This catch block, will it be node? What will be the output exactly this time? What do you think? Yes, if I run this code, what will be the output? Yes, it terminates abruptly in the middle of the execution. This time, I can say that the exception is not handled. This time, I can say that the exception is not handled. I can say that this catch block is not appropriate to handle the null pointer exception. So this catch block is appropriate for handling which type of exception? This catch block is appropriate for handling which type of exceptions? arithmetic exception. It can only handle the exceptions which are of type arithmetic exceptions. Yes. So if you want, we can add a catch block for null pointer exception. So you see, as of now, I'm sorry. Before that, let me run this code once. You can get null pointer exception. You get null pointer exception. Okay. So that means actually this time the exception is not handled. So there is no, this catch block is not invoked. You see, the catch block is not invoked. The program terminated abruptly. So if there is no exception handler, then what the runtime system does? What did I say? If there is no exception handler, then what happens? Yes, the runtime system will hand over the exception object to the default handler by calling it. It will call the default handler. So default handler will simply print the error details and it will terminate the program. Simply, it will terminate the program abruptly in the middle of the execution itself. That is what happens, right? Yeah. Okay. You see, what I will do here, I'll add a catch block, null pointer exception. You see, catch block for arithmetic exception, catch block for null pointer exception. I'll add one more catch block. So let's see, catch block for exception. I can also do this. So this time, you see, because we got null pointer exception, so the second catch block will be invoked. What about the third catch block? Catch block for exception. Is it not invoked? No, it will not be invoked. Okay. Okay, fine. So this time catch block for null pointer exception will be invoked. See, that's it. Catch block for NP, end of main method. Fine. And one important thing here, you know, the catch block for super type exceptions, you should not add it in the beginning. Don't add catch block for super type exceptions here this way. So you should not do this. Why we should not do this? What do you people think? See the catch block for that exception, it should not be added in the beginning. Yes, you see the catch block for exception which you got here. The catch block for exception itself can handle any type of exception. Catch block for exception itself can handle any type of exception. So that means the second and catch block, there is no need for them. Even if you write such code, it is actually considered as unreachable. That code is unreachable. Yes, it's unreachable code. That means that code which never executes. So this is what the error is. Check the error once. It says unreachable catch block for arithmetic exception. It is already handled by the catch block for exception. It says only it is handled here. The same you'll get it here. Okay, so you can add any number of catch blocks. Why we need a separate catch block here? Yes, you see, here we got an option to handle each type of exception separately or individually. You see, we can handle each type of exception separately itself. So basically, we got that option. We can handle each type of exception separately. Okay, so this is about the try catch. Now let's move on. I'll talk about types of exceptions. Types of exceptions. we can broadly classify the exceptions into two types: unchecked exceptions and checked exceptions. So we can broadly classify the exceptions into two types: checked exceptions and unchecked exceptions. So what are unchecked exceptions? What do you people think? Okay. Yeah. First, we'll start with unchecked exceptions. Unchecked exceptions means the exceptions which we don't need to handle. We don't need to explicitly handle unchecked exceptions. Uh, Not by the JVM, I can say. Let's see what does that mean. I can say that unchecked exceptions are those exceptions which we don't need to handle them explicitly. We don't have to handle them explicitly. We don't need to explicitly handle unchecked exceptions. So compiler is never bothered whether you handle these exceptions or not. Compiler will not be bothered. You'll find that most such exceptions, I can say that we can avoid them. For example, you know, we have this null pointer exception. I can say that it is actually an unchecked exception. You can say it is actually an unchecked exception. So we don't need to explicitly or manually handle this exception. We don't need to explicitly handle this exception. Why so? Let's see. I have a question for you people. Can we avoid can we avoid these exceptions? Can we avoid this exception? What do people think? Uh, I can say that it is possible to avoid this exception. Uh, so what we can do is here, you know, we can check this account. You can check this reference. If account is not equal to null, if account is not equal to null, then only use that reference to call the method. So you see, this time, will there be any exception? This time, will there be any exception? No, because you see, if that reference is null, if the reference is null, you will find that that method call or method invocation will not work. Okay, yes, it will not work. So that statement will not execute. Let's see. So that means we can avoid this exception, right? We can avoid this exception. So when we can avoid this exception, why to handle it? You got the point, all of you. If we can avoid this exception, why to handle it? So you better avoid it, right? So if you avoid the exception, then you don't need to handle that exception. You see, instead of avoiding that exception, or suppose I will not avoid the exception, but I will try to handle the exception. So what it means here, what does that mean? What do people think? Instead of instead of avoiding it, handling the exception, we are unnecessarily raising that exception. Who is responsible for that exception? We developers are responsible for raising that exception. We developers are responsible for raising that exception. How? You see, we could have checked for that reference, right? We could have checked for that reference. If the reference is not null, then only we can use that reference. Otherwise, don't use it. We have this possibility. We got this possibility. Okay. So it's something like prevention is better than cure. Yes. So these are unchecked exceptions. So unchecked exceptions, we can avoid them. So we don't need to explicitly handle this unchecked exceptions. We don't need to explicitly handle unchecked exceptions. So now, how do we know whether a given exception class is a checked exception or unchecked exception? How do we know whether the given exception class is a checked exception or unchecked exception? Please make a note of it regarding the checked exceptions. Runtime exception class, runtime exception class, runtime exception class, and all its subtypes are unchecked exceptions. Runtime exception class, runtime exception class, and all its subtypes are unchecked exceptions. Once again, I'll repeat it. Runtime exception class and all its subtypes are unchecked exceptions. Okay. So now let's move on. We'll talk about checked exceptions. So is anyone familiar with checked exceptions? Checked exceptions. Okay, before we talk about checked exceptions, I have a last point. So hope you understood what are unchecked exceptions, right? So exceptions which we don't need to explicitly handle. Compiler never expects us to handle unchecked exceptions. Instead, it expects us to avoid those exceptions. Okay, hope you got it, all of you. Okay, so unchecked exceptions which we don't need to explicitly handle them. It is better to avoid them instead of handling. Okay, next we'll talk about checked exceptions. So what do people know about checked exceptions? Okay, IO exception is an example of checked exception. I do agree. And what else? You know, checked exception means I can say that the compiler mandates us to handle checked exceptions. So we need to definitely handle checked exceptions. We need to definitely handle checked exceptions. Okay. Why we need to handle this checked exceptions explicitly? No. I can say that checked exceptions are those exceptions which we need to explicitly handle them, right? Why we need to handle checked exceptions? Because you know what? We cannot avoid them. Because we cannot avoid them. It is not possible to avoid checked exception. Okay? Yes. So we'll see why we have to handle these exceptions mandatorily. Let's see. We'll see what is it. Now, to make you people understand the checked exceptions, so let's take this example. You see, so in this example, we have a Java application. It connects to the JDBC, sorry, database server. We got a Java application which is supposed to connect to the database server. So your database server is hosted on one machine and your Java application is hosted on another machine. And these two machines are connected through the network. So when the Java application is trying to interact with the database server, when the Java application is trying to interact with the database server, you see, it will use this network. So through this network itself, you see, Java application will be able to connect to the database server. So let's say Java application when it is trying to establish the connection. So what if when the Java application is trying to establish the connection, what if the network fails? So it is one sort of exception, right? It is actually an exception. It's when the application is trying to establish the connection, the network fails. The network has gone down. Even after establishing the connection, you see, the network may go down. So the Java application will not be able to interact with the database server. You see, I can say that we cannot avoid this exception. We cannot avoid this exception. We cannot avoid this exception. You see, because we got a network issue. Your Java application, will it be able to fix that network issue? Your Java application, will it be able to fix that network issue? No, it's beyond the scope of the Java application. It is actually beyond the scope of the Java application. So in this case, your Java application, it cannot do anything. It is beyond the scope of the Java application. Okay. So that means here in this case, at most we can handle the exception. That is what at most we can do in this case. Okay. Yeah. So let me show you people pragmatically. You see, because we cannot avoid this exception, so compiler always mandates you people to handle this exception. It will force you people to handle this exception, you can say. It's okay. So now here in Java, in the API in Java, we have a method called as get connection defined in the driver manager class. So there is a predefined class called as driver manager. In that driver manager class, we got a method called as get connection. We got a method called as get connection. So you can pass that connection URL. As of now, we don't have anything. Don't worry. You see, the get connection method, when it is invoked, it is supposed to establish the connection with the database server. If it is able to successfully establish the connection, then it is supposed to return that connection object reference. It is supposed to return the connection object reference. You see, but we are getting an error. Let's see what is that error, what it says. So it says unhandled exception type SQL exception. It says we are not handling the exception. So what to do now is, so what are we supposed to do now is, it says, you see, we are not handling the exception. It says unhandled exception, SQL exception. It says we are not handling this exception. So it is asking for, it is asking us to handle that exception. You see, earlier compiler never did this. Only in this case, you see, it is asking us to handle the exception. It is asking us to handle the exception explicitly. So we can use try catch. You see, so once I add try catch, the error vanishes. You see, now there is no error. That means because we are handling the exception, you won't find any error. So hope you understood this, right? So we have to explicitly handle this exception. Why we need to explicitly handle the exception? Yes. What is that point? Important point here. Why we need to explicitly handle the exceptions here is, mm, why compiler is forcing us to handle the exception? That's the question. Because we cannot avoid these exceptions. We cannot completely avoid these exceptions. So that's the reason why the compiler is forcing us to handle them. At least we have to handle them. Anyways, we cannot avoid them. So there is a chance that there can be a checked exception. Okay, there is a possibility, that's it. Yes. There is a possibility that there can be a checked exception. So that's the reason why, you see, we are trying to handle that exception. Okay, you know, I can say that Java is completely forcing us to handle this exceptions, right? Checked exceptions. So is there any alternate for us? Yes, there is an alternate. If you don't want explicitly handle the exception, okay, that's what to do. So if you don't want to explicitly handle the exception, then there is one possibility. We can delegate the task of handling the exception to the default handler. Okay, we can delegate the task of handling the exception to the default handler. Okay, so you need to write this throws SQL exception. So by adding this throws clause here, throws SQL exception, is saying that will not handle the exception explicitly. Instead, we'll delegate the task of handling the exception to the default handler. So at every main method you have a default handler associated, right? Simply we are delegating the task of handling the exception to the default handler. So what exactly the default handler does now? So we are delegating the task of handling the exception, right? Let's assume that we have that SQL exception. So in that case, what exactly the default handler does? You know, the default handler will simply print the exception details and it will terminate the program. It will print the error details and it will simply terminate the program. That is what it does. Okay. Okay, fine. Now, actually, this is for main method. But for suppose, let's say we have another method, something like this. Again, here also, so compiler first of all will force us to handle this exception. Compiler will force us to handle this exception. Now we can add try catch. That is one possibility. And what is the other possibility here also? we can use throws clause, but the meaning of the throws clause will change when it comes to non main methods. For other than main methods, you see, for other than main methods, the meaning is slightly different. So what is that meaning? Sorry, what is that meaning? So here in this case, it indicates that this method will not handle the exception. This method, it won't handle the exception. It will delegate the task of handling the exception to the method. It will delegate the task of handling the exception to the method which has invoked this method. So which method has invoked this process method? As of now, no one is invoking it or no one is calling it. So you see, so for other than main method, the throws clause, it indicates that we don't want to handle the exception, but instead the main method which you got here, okay, you can write some code in that. We don't want to explicitly handle the exception, right? So we'll use throws clause. Using throws clause, we're delegating the task of handling to the method which is going to call this method. So which method will call this method? In this case, no method is calling it. So whichever method is calling this method, process method, it will handle that task of handling the exception. It will take care of handling the exception, I can say. Yes. So now for suppose if I do this, that means we are calling process method here. Sorry, we are calling process method from the main method. We are calling process method from the main method. So that means here we are using throws clause, which indicates that we don't want to handle the exception. Instead, calling method will take care of it. So which method is calling that process method? Main method. So main method is calling the process method. Main method is calling the process method. So main method should handle that exception handling task. Main method is supposed to handle that exception handling task. But is main method handling that exception here? No, main method is not handling that exception, right? That's the reason why we are getting error here. So what to do? Now, how can we avoid this error? What do people think? Either we can use try catch, either we can use try catch, or you use throws clause. Yes, that's right. Either use try catch or use throws clause. That's right. So hope you people got it. So this way we can handle the checked exceptions. So how do we know whether a given exception class is a checked exception or not? Yes. How do we know whether a given exception class is a checked exception or not? Okay, please make a note of it. So how do you know whether that given exception class is a checked exception or not? Except runtime exception and its subtypes. Hmm. Yes. So given exception class, just a minute, just a minute. Yeah, given exception class, if it is not a subtype of runtime exception, the given exception class, if it is not a subtype of runtime exception, if it is, sorry, oh, one small pointer. If the given exception class is not a runtime exception class, if a given exception class is not a runtime exception class or its subtype, if the given exception class is not a runtime exception class or its subtype, then we can say that it is checked exception. Okay? If the given exception class is not a runtime exception or its subtype, then then we can say that it is a checked exception. Then it is a checked exception. Other than runtime exception and its subtypes, all other exceptions are checked exceptions. Or you can also make a note of it this way. Except runtime exception and its subtypes. Except runtime exception and its subtypes. So all other exceptions are checked exceptions. Okay, so you can test it that way. If a given exception class is not a runtime exception class or its subtype, then it is a checked exception. That's it. Okay. I'll give you a small example to make you people remember this concept for a long time. Actually, handling, handling the checked exceptions. When we talk about handling the checked exceptions, you see, you'll find that either we can use try catch or close class, right? Yeah. But why we need to handle that exceptions? Because we cannot avoid it, as I told you before. Because mainly because we cannot avoid them. The main thing is we cannot avoid these exceptions, checked exceptions. So there is always a possibility that these checked exceptions may occur. Okay. In general, I'll give you an example. For suppose, let's say you're going for a long drive. First of all, you'll make sure that you have enough water, or especially if you're going in a car for a long drive. Of course, you go in car. Okay. So you'll also make sure that we got a stepney tire for that car. We'll carry an appropriate stepney tire for that car. So why we carry stepney? Because if by any chance, if the tire punctures for some reason, we don't know, right? It's highly unpredictable. So that is the reason why. Okay, always you'll take a stepney. You'll carry a stepney. It's a precautionary measure which you're taking. It doesn't mean that definitely you'll have the tire will burst or it will puncture. Doesn't mean that the tire is going to puncture. So it's only just a precautionary measure which you're taking to make sure that you have a smooth drive without any issues. Similarly, even when you're writing the code, so there is a possibility of an exception being raised, especially checked exceptions. And if there is any possibility that of a checked exception being raised, if there is any possibility of checked exception being raised, in that case, you know, we can simply handle them instead of we cannot avoid them. Simply we have to handle them using try catch or delegate the exception task and exception handling task. You see, by writing that exception handling task or exception handling code, I'm sorry, by writing the exception handling code, you're just taking some precautionary measures, I can say. If at all, if there is any exception, so this exception handler will execute. The exception handler will execute, right? So this is about checked exceptions. So hope you have got it. So any questions in this regard, please let me know. Okay, so hope everyone got it. So checked exceptions, unchecked exceptions. try catch, we have to go through finally, and there are a few more things which we need to see. So there is nothing like best. It depends on the situation. So in few cases, you know, we may need to explicitly handle. In few cases, we can just leave it because there may not be much scope to handle it, or there is no need for you to handle it. Yes, we'll see that. I'll show you people. Okay, it depends on the situation. So in some cases, you'll delegate the exception handling task. In some cases, we need to explicitly handle it. So going forward, so it's a regular practice for us. We'll be regularly using this exception handling. Okay. Yes. So any other questions, please? You see, that is what I said. It's beyond the scope of the Java application. Network connection is not under the control of Java. The connection may go down at any time. Always there is a possibility. If it is actually beyond the scope of the Java application, I can say. It is beyond the scope. Otherwise, we could have avoided them. It's not possible to avoid them. You see, for suppose you want to interact with that, for suppose, let's say you want to test the connection. First, let's say you have tested the connection, you have established the connection, and then you're using that connection. After checking whether the connection, sorry, after establishing the connection also, there is a possibility that the network may go down, right? So beforehand itself, every time it is not possible to check, especially in this case. Okay, you may first check that connection, you may establish the connection. So if everything goes fine, you'll use that connection, you'll interact with it, right? Yeah. So even after establishing the connection, that network may have some issues. It may go down. The network may have issues and may go down. So it's not reliable. Okay, at least to some extent. I can't say that mm, always the network will go down. 99.99% it won't. At least 0.01% is there. There is, of course, a slim chance. Yep. So hope you people got it. So any other questions, please? Okay, good. So if it is clear, then I'll stop it here. Okay. I got few more things, but I'll talk about it in the next class on Monday. Okay. Yes. So we'll meet on Monday and we'll continue our discussion. In the next class, we'll complete this exception handling and we'll move on to, yes, we'll complete it. We'll be able to complete it and we'll move on to the next topic, that is IO streams, followed by collection API. Okay. Yes. Next week, hopefully we should be able to complete this core concepts and we'll move on to the advanced concepts. Okay. Yeah. Fine. So that's all. Thank you all. Bye bye. Have a nice day. Again, we have a class on Monday at our regular time. We have a class on Monday at our regular time.